Hello there, and in this episode, we're going to look at real life uses of ratios. So, maps include a scale which tells you the relationship between the distances on the page of the map and the distances in real life. So, map scales can be written in a ratio such as 1 to 5,000. And this ratio means that the map every unit on the map represents 5,000 units in real life. So for example, 1 centimeter on the map might be 5,000 centimeters in real life. And then you can work out distances from this. So to work out the distance on a map, we measure the scale given to find out the relationship. So it might be 1 centimeter equals 100 meters. And then you measure the distance on the map and use the relationship to convert this to the distance in real life. So say it's 5 centimeters on the map and it's 1 centimeter is 100 meters. So 5 centimeters would be 500 meters. So let's have a little question for you to think about. A map has a scale of 1 centimeter to 6 kilometers, and the distance between two shops on a map is 10 centimeters. What's the distance between the shops in real life? So 1 centimeter to 6 kilometers is the scale of the map, and it's 10 centimeters on the map. Well, if it's 1 centimeter is 6 kilometers, 10 centimeters will be 60 kilometers. Now, another example is if 1 centimeter on the map is equal to 2,000 centimeters in real life, we can say that's the ratio 1 to 2,000. Ratio is also used in shapes to find between similar shapes, and you can find the corresponding sides on the same shape. So if one shape is an enlargement of another one, you can use the ratio of the size of the two shapes to work out any missing sides. So when a 2D shape is enlarged by a scale factor, that basically means it's been multiplied by that scale factor and it's that many times bigger. Now we say that the ratio of each original size to the enlarged size is 1 to the scale factor. So for example, we've got a triangle that's been enlarged by a scale factor 2. If a side is 3, one side of it is 3 on that triangle, and it's been enlarged by the scale factor 2, the larger triangle will have a side of 6. Now, you can also think of scales in shapes and animals. So take an adult polar bear. That appears to have been an enlarged version by a scale factor of about 5 relative to a baby polar bear. But they look very similar. They're just an enlarged version of it. So if we've got a ratio and it's equivalent to 2 centimeters, is the same as 5 kilometers, how would we write that ratio for a map? Well, the thing you need to think about here is that one's in centimeters, one's in kilometers. So we need to convert both to be in centimeters to make it a ratio, because remember, the units need to be the same. So we can say that 5 kilometers is the same as 500,000 centimeters. So we can say it's 2 to 500,000. 2 to 5 would be wrong, because that would be saying 2 centimeters to 5 centimeters is the scale. Another thing to think about with this triangle. So if we enlarge by scale factor, let's say 3 this time. So if we've got a side length of 4 centimeters and we've enlarged by scale factor 3, the new shape, the larger shape, will have that same side will be 12 centimeters.